Chapter 1 is about exploring categorical data. And in the first lesson, lesson 1.1, we're going to look at ways to display categorical data by graphing. In statistics, we use the term variable often, and we define that as a characteristic or an attribute of an athletic performance. Typically in math, we use the term variable to mean an X or a Y or some other letter that stands for an unknown value. But in statistics, it represents a character or an attribute or some information that we can collect about an athletic performance. Variables can fall into one of two different types. They'll either be categorical variables or numerical. Categorical variables are variables whose possible outcomes can be organized into categories. For example, if I was going to survey students in my class, I could ask them about their eye color, and their eye color would be categorical because everybody's response would either be brown, blue, green, or something like that. They'd all be categories. In baseball, we can categorize the results of an at-bat, and those would be something like hit, walk, or strikeout. Numerical variables are variables whose possible outcomes can be either counted or measured. So in other words, their results are numbers. For instance, in baseball, if we measured the distance that a batter hits a ball, that would be something that would be numerical. Categorical variables are usually summarized by reporting percents. For example, when we look at a batting average for a baseball player, we are looking at how many hits the baseball player was able to get out of the total number of attempts. Numerical variables are typically summarized by reporting averages. So when we look at the distance that a batter hits a ball, if the player repeats that 10 times, we can average the 10 distances together and report the average distance. In example number 1, we're going to look at several variables that are associated with soccer and identify each one as either categorical or numerical. The amount of time the referee adds at the end of the game would be numerical because that would be something you would measure with a stopwatch. The number of saves a goalie makes is also numerical. That would be something that you would count. So anything that you can count or measure is numerical. The outcome of a game, whether the game results in a win, a loss, or a tie, would be categorical. There's nothing to count or measure here. The number of penalties in a game would be numerical because we count those. The color of the home team's jerseys, categorical. And finally, the distance that a player can kick a ball would be numerical. In example number 2, we're going to look at different statistics that are calculated from variables related to the 2017-18 NBA season. We're going to circle the ones that are calculated from a categorical variable. Now notice in this case, the statistics that we're reporting are all numbers. But what we have to think about is what were the types of variables that were originally collected in order to calculate that statistic. So for example, Dwight Howard's field goal percentage was 0.555. That would be a categorical variable because when we calculate that field goal percentage, we would count the number of successful field goal attempts. So did he make it or miss it? And that would be categorical, and divide that by the total number of attempts, and that's a percentage. In letter B, it says James Harden scored an average of 30.4 points per game. That one's numerical because to calculate that, we would take the number of points that he scored in all of his games. We would count those up and then divide it by the number of games that he played in. Letter C, that one would be categorical because that's a winning percentage. And to calculate a winning percentage, we would look at wins and losses. That would be a categorical variable. The LA Lakers averaged 15.8 turnovers per game. Again, that one would be numerical because we would count the number of turnovers per game. So the number of turnovers is a numerical variable. And the last one, Kyrie Irving played approximately 32.2 minutes per game, also would be numerical. We would count up the number of minutes he played per game or measure with a stopwatch, and we can calculate the average by dividing by the total number of minutes. So that's a numerical variable. Now, what we often want to do in statistics is make a distribution, and a distribution is a table or a display that gives all the possible outcomes of a variable and how often it takes on those values. With categorical variables, there really are only about 3 types of graphs or displays that you can make. First is a pie chart, number 2 is a bar graph, and number 3 is a segmented bar graph. And you've probably seen many of these before, maybe not a segmented bar graph, but you have seen the rest. You probably know, for example, that a pie chart or a pie graph displays the possible outcomes of a categorical variable as slices of a circle, with the area of each slice being proportional to how often each corresponding outcome occurred. In example number 3, we're looking at field goal shooting percentages for LeBron James during the 2018 playoffs. Notice we separated his data into road game and home game performances. And based on this, then we can then write a sentence summarizing what these two pie charts show. Typically, when you describe a distribution, we want to include information about who, what, and when the graphs are showing us. So the who in this case would be LeBron James, the what is his field goal shooting percentage, and the when is during the 2018 playoffs. The when is important because we want to be sure we let the people looking at the graph know that we're talking about just the playoffs in 2018 and not the entire season or not his entire career. So one thing we could say here is that LeBron made more field goals in home games than in road games during the 2018 playoffs. Notice the other thing about the graphs is that you don't know how many field goals he made or missed, but you're looking only at the percentages, which is often the most useful way to compare categorical data. Now we're going to look at a bar graph, and a bar graph displays the possible outcomes of a categorical variable as individual equally wide bars, with the height of each bar being proportional to how often each corresponding outcome occurred. And so we have an example of a bar graph here, and this bar graph shows the same information that we showed on our previous circle graph or pie chart. So notice here, instead of having two circles, we have two groups of bars, one group for home and one group for road games. We have, for the home group, we have one bar being at a height of 57 and the other one being at 43. And here we have this bar being at a height of 51 and the other one being at 49. And so we have a key over here, made and missed. Now to the side, we have relative frequency, and relative frequency is just another term for percent. Notice the key over here again, super important because when you're doing two bars or more, sometimes for each group, you want to specify which bar stands for which part of your data. And we have labels on the axes, right? Also very important. Finally, we're going to make what's called a segmented bar graph. And a segmented bar graph displays the possible outcomes of a categorical variable as slices of a rectangle, with the area of each slice being proportional to how often the corresponding outcomes occurred. Segmented bar graphs should always show percents. When you're making a regular bar graph, a lot of times we use percents, but it's not required. With segmented bar graphs, we must show percents. So we're going to create a segmented bar graph showing LeBron James' field goal performance in home games and road games during the 2018 playoffs. So first thing we're going to do is we're going to put a title on the top, and the title shows the who, what, and when. We're going to label our vertical scale, and here I'm going to label this as percentages. Notice I'm counting by 10, so I have a consistent scale. You could also label those as decimals. So instead of 20, 40, 60, 80, I could do 0.2, 0.4, 0.6, 0.8, and then it's not necessary to use the word percentage along with that. We're going to set up our labels on the horizontal axis because remember, we're dividing our data into home and road. Now, instead of doing two separate bars, we're going to make one bar for each home and one for road, and they're going to stack. So for example, in home games, if we look at the last bar graph, we know that he made 57% at home, and therefore he missed 43. And so that missed section will get stacked right on top of the made one. So made and missed total make 100%. On the road, he made 51% and he missed 49%. So 51 and 49 stack up to make 100%. So in a segmented bar graph, your bars should always total 100%, and they should be divided within the bar according to the different categories of your variable. And then again, don't forget your key. So really important with a segmented bar graph, especially that you kind of specify which part of the bar is which for your two variables. Please do assignment 1.1 in your homework packet.